Hi and Assalamualaikum. My name is ALLYSSHA binti Abdullah. My matrix number 63571 and my other group member is Philip Ngue Mong 62346 and we are from group 27. So this is our presentation outline. First, we are going to introduce the project requirement. Next is we are going to explain the manufacturing processes that includes to manufacture the product that we chose. Uh, and then we are going to talk about the possible defect that normally occur for each manufacturing processes and way to minimize it. Uh, Next is the design consideration for each manufacturing processes with respect to the product. And then selected manufacturing process optimization, and last but not least is the conclusion. As for the introduction, the project requirement is started here, which throughout this project report, things that will be discussed are as listed as and shown below, which is illustration and justification of selected process for each manufacturing processes, relation of defect that normally occur for each manufacturing processes and ways to minimize the defect. That is the design consideration for each selected manufacturing process with respect to product. And last but not least, the main point that will be discussed in this presentation is the optimization of selected manufacturing processes to manufacture the product. So we have agreed that there are four manufacturing processes that will be included to manufacture this traditional string relaxed chair, which is the first process is the sand casting. Second is the non-metal forming, which using direct extrusion. Um, Next is the metal forming, which using indirect extrusion. And last but not least is the mechanical fastening, which explain the joining process by using bolt and nut.
Sand casting. So sand casting is the most common casting method that employs the expandable sand molds to shape complicated metal parts that can be made of nearly alloys. So sand casting usually has a low production rate since the sand molds must be broken in order to remove the components or part. And then a furnace metal patterns and sand mold are mostly used in the sand casting method. Okay, process cycle for sand casting. So the sand casting process is divided into the 6 primary stages. Alright, so the first step is place the mold pattern in sand. The first step in sand casting is to put the mold pattern in the sand, and the mold has because the mold has direct impact on the size and shape of the casting. So as a result, the manufacturers must develop the new molds in order to produce the metal products and components in complex size and shape. The second stage is set out the gating system. So sand casting make use of a gating system. Gating system consists of a pouring card and tunnels or gates to the mold. It is used to funnel the molten metal into the mold cavity. So usually manufacturing companies will set out a gating system such as this after placing the mold pattern in the set. The third stage is remove the mold patterns. So with the gating system set out, manufacturing companies can then remove the mold pattern from the sand, and then the mold pattern is not longer relevant at this point. When the mold pattern is placed inside the sand will take its shape. As a result, the mold pattern can be removed. Alright, the fourth step is pour the molten metal in the mold cavity. So the molten metal is now ready to pour into the mold cavity. So sand casting is compatible with a wide range of metals and alloys, including iron, brass, aluminium, bronze, magnesium, zinc, and things. So manufacturing usually need to determine what type of the temperature that are suitable to that molten metals. Alright. So next step is wait for metal order to solidify. So the manufacturing industry must wait for the molten metals to solidify after it has been poured into the mold cavities. Again, various metals is require different amount of time to solidify. As the molten metals cool, it will transition from a liquid to a solid state. So the last step is break open the molds to remove the metal casting. So breaking open the molds to extract the new form metal casting is the sixth and the final stage of the sand casting. Mold patterns are usually reusable, but the final molds are not. As a result, any times a new metal want to create it, they must make the new molds. Okay, the next is the non-metal forming. In this project, we decided to use extrusion as our non-metal components, right? So plastic extrusion is a high volume manufacturing method that involves the melting raw plastic and forming it into a continuous profile. By weather stripping, fencing, that railing, window frame, plastic fern, and sheeting, all are these can be generated by extrusion with the 1000 custom profiles. These are the process cycle for plastic extrusion process. So normally the plastic extrusion process consists of 5 steps. Alright, so the first step is the raw material like granules, pellet, or powder are loaded into a hopper and then feed into a long heated cylindrical chamber. Right, the step 2, the beads will flow from the hopper down through the feed drop, which dispenses then onto a large spinning screw operating within a horizontal barrel. And then at the end of the heated chamber, the molten plastic is forced through a small opening called a die to form the shape of the finished product. Step 4, as the plastic is extruded from the die, it is fixed onto a conveyor belt for cooling. Cooling can be happen by air or water. The process is similar to injection molding process except that melted plastic is forced through a die instead of into a mold. So the die will go into form an individual plastic profile so that the plastic will flow smoothly and evenly from the cylindrical profile of the extruder into the final profile shape. Consistency in this flow is critical in order to achieving the end of the product with integrity.
For this metal extrusion, we chose indirect extrusion, or also known as backward extrusion. It is under hot extrusion, and in this process, the direction of the force is applied by the ram, and the direction of extruded metal is on the opposite side. And actually, it is quite similar. The process cycle for this metal extrusion is same as the non-metal extrusion as explained by Philip. The next process is joining process. So since this product is able to be folded, the best joining process is by using mechanical fastening, which is bolt and nut.
Next, we are going to talk about the possible defect for each manufacturing process. Alright, a product defect is any characteristic of a product which hinder its usability for the purpose for which it was designed and manufactured. So a manufacturing defect occurs where something in the manufacturing process causes the product not to be made accordingly to the design. Okay, next we are going to talk about the sand casting defects. Alright, the problem is the porosity. So the probable causes is because of the high pouring temperatures, gas dissolved in the metal charge, lack flux use, molten metal is not properly degassed, slow solidification, casting. So the suggested remedies is regulate the pouring temperatures, control the metal composition, increase the flux proportion, and ensuring the effective degassings. Okay, the second one is inclusion. Alright, so the probable causes is because of the faulty gating system, faulty pouring, or the interior molding in terms of the dimension. Alright, in terms of their size, dimension, wall thickness, and something else. Alright, soft ramming of the mold, rough handling of the mold and core. Okay, so how do you going to solve this problem? By modifying the getting system, improving the pouring to minimize the turbulence, use of superior sand of good strength, or provide hard or ramming. Okay, so next is plastic extrusion defect. So the problem is bubbles in the extruder. So mostly it's caused by the moisture absorption, right? Track A, polymer degradation, depolymerization of the polymers, incompatible additive. So how do you going to solve this problem? Material must be pre-dry in hot. The pellet used as a starting material. Avoid the overspeed of the extrusion. Avoid overheating. They must have the accurate temperature control. Uh, all right, for the specific polymers.
So moving on to the next main point of this project, which is the normal defect that occur in manufacturing process, which is in this indirect metal extrusion, is surface cracking. The probable causes might be because of the extrusion speed is very high, which lead to high strain rates and associated heat generation. This also causes because of high friction and surface chilling of high temperature billets in the hot extrusion process. So the suggested remedies is to increase the extrusion ratio, limited lubrication, lower dummy block temperature, optimize die design, and maintain enough butt length.
A. Design consideration for sand casting process. So the first thing that we need to concern about is the parting line. In sand casting, a parting line is the point from which the draft angles change direction, while the foundry must have the skills and expertise to position the parting line. So engineering product designers should be conscious of it because it can determine the consistency and expense of the casting process. The second one is that you should concern about is wall thickness. In sand casting, the volume to surface area ratio is important for achieving even solidification and avoiding the cavity forming. The rate of solidification is proportional to the square of the volume or surface area ratio. Casting part with low volume to surface ratio area ratio can solidify better than section with a high volume to surface area ratio. The extrusion design consideration. So the first one is regular wall thickness. So variations in thickness can render it difficult to control the flow of plastic content through the instrument, resulting in uneven cooling and distortion of the finished profile. Irregular extrusion wall thickness may also cause the manufacturing issue and raise the production costs. Alright, the second one is the length tolerance. So thermoplastic contract and expand with the temperature and cutting plastic profile to a very critical lengths can add unnecessary to the costs.
As for the design consideration for metal extrusion, when designing a metal extrusion process, the geometric profile of the extruded section is an important factor affecting the forces involved: metal flow, die wear, and part quality, which some cross-sections when extruded will produce undesirable force distribution and metal flow. If possible, it is desirable to design for manufacture. Die wear and breakage are primary consideration of the manufacturing process designer when designing a metal extrusion operation. Controlling material flow is essential in metal forming manufacture. In addition, the stress applied to the die as a result of this metal flow must be calculated, and the mold must be designed to handle these forces. Next is the design consideration for mechanical fastening, which using bolt and nut. First criteria that have to be considered is the size and the shape of the bolt and the nut to join the parts of the product. This is because the product is expected to be foldable. Besides, the correct and appropriate size and shape of bolt and nut will increase the safety of the user and help to boost its appearance. Second is the location of where the joining process by using bolt and nut to be done. This is the most crucial factor to be considered as it will affect the reliability of the product safety.
Next, we are going to talk about the optimizations of the selected manufacturing process. So the first one is through a simulation software solutions. All right, the MedMarSoft can be used to study the predicted result of the affected parameter. So parameters such as the filling patterns, pressures, velocities, cooling rate, solidification, and defects can be estimated before going to the prototype. So the simulation of the casting processes can help to reduce the experimental testing and provide the best solutions of the process and material selection. So thus it makes the design and development process can be more cost efficient. Okay, the next thing is optimizations of the plastic extrusion process. So the first one is through in tooling maintenance. So tooling maintenance is needed to maximize the extrusion performance, consistency, and overall productivity for medical tubing application. The use of dedicated work card exclusively reserved and equipped for the extrusion head maintenance is also recommended. The second one is cleanliness is critical. Clean part is especially those with the sealing surface are critical to product production and the success of the end of product. So these surfaces are the control surface that maintain the uniformity in the tubing and receive the most care and consideration throughout the production. So remember that even a speck of the soil weighing a few thousand of an inch will impact the precision of the machine alignment.
Last but not least, the optimization of mechanical fastening process using bolt and nut. There are few fasteners selection criteria to be met for industrial application. First is the material of construction, which emphasize the mechanical properties of the bolt and nut. For example, to ensure whether it has a good strength and high corrosion resistance to perform its task as the product will be folded. Installation process where the location of the bolt and nut to be placed is sufficient to support the fastener to perform its task, which is to join the parts of products with less defect. And last but not least is the applied load of the fasteners. This is crucial as it is to make sure the bolt and nut will not loose and will be able to hold the parts of the product in place. As a conclusion, there are four manufacturing processes involved to produce or to manufacture this traditional string relaxed chair, which is sand casting, um, non-metal forming, which is by using extrusion, direct extrusion. Third is the metal forming process by using indirect extrusion. And last but not least is the joining process, which is using a mechanical fastener by using bolt and nut.